Today, we are going to dive into how AI learns to read, and, maybe more importantly, why most of the words it looks at are basically just noise. We're going to uncover a brand new method that helps AI find the really crucial stuff in that sea of noise, making everything from your spam filter to your newsfeed way smarter.
You ever stop and think about that? How your inbox just magically knows which emails are junk? Or how a news app can perfectly sort articles into sports or politics? Well, the magic behind all that is a kind of AI called text classification.
You know, at its core, this whole thing is really just about teaching computers to read and sort stuff. But here's the catch. Computers don't get words like we do. They have no idea what sarcasm is, or context, or any of that human nuance. So how on earth do they manage it?
Well, they do what computers do best. They turn language into pure data. For a machine, a sentence like, "Deep learning is a subset of machine learning," has no real meaning. It's just a list of words, what data scientists call terms, and a count of how many times each one appears. Every unique word becomes a feature, and the AI uses this big collection of features to make its decisions.
Now, that whole approach works just fine for a single sentence. But what happens when you try to scale it up? When an AI has to analyze thousands or millions of documents, suddenly it's drowning in hundreds of thousands of these features. And that creates a massive problem. Just think about this for a second. According to the research we're looking at, something like 80% of all the data a company deals with is text. That's just a staggering amount of unstructured information to sort through.
In the world of data science, this problem has a name: high dimensionality. And you can think of it like this. Imagine trying to find your way in a city with millions and millions of streets, but only a tiny handful of them will actually get you where you need to go. For the AI, most of the words in a document are just noise, useless streets that don't help it figure out what the document is about.
And that brings us right to the heart of the problem, doesn't it? How can we possibly help an AI sift through all of that noise and find the very few words that actually matter for telling one document from another? Researchers have been chipping away at this for years, right? They've been creating all sorts of methods to try and rank how important each word is. But, as we're about to see, these earlier attempts, they all had a pretty critical flaw. So let's take a look at a couple of these older techniques, RDC and its successor IRDC. Now, they were decent attempts, but they just had this balancing problem. Imagine one method giving a huge score to a word that only shows up once, just because it's rare, while totally undervaluing a word that appears consistently across all the sports articles. That's the flaw right there. They just weren't giving the right amount of weight to the right kinds of words. And this, right here, is where the hero of our story comes in. A new, much improved method that was designed to fix this exact problem.
It's called BRDC, which is short for Balanced Relative Discrimination Criterion. I know, it's a mouthful, but the name really tells you everything. Its whole goal is to create a much more normalized and especially a more balanced way of scoring words, so it can get a much truer sense of which terms really help distinguish one category from another.
The whole process is actually pretty logical. It works in 4 main stages. First, it cleans up all the raw text. That's pre-processing. Then comes the secret sauce. It uses its new balanced metric to pick out only the most important features. After that, it builds the actual classification model, and finally, it analyzes the results to see just how well it did.
So having a shiny new method is great and all, but how do you actually prove that it's any better than what came before it? Well, you need a really reliable scorecard. In machine learning, you can't just say your model feels better. No, you have to measure its performance with cold, hard numbers. And to do that, researchers use a few really important tools.
One of the most critical tools is something called an ROC curve. It's basically a graph that shows you how good a model is at telling two things apart, like a spam email versus a real one. A perfect model would have a curve that just hugs that top left corner. So the goal is to maximize the area under this curve, a score we call the AUC. So what does that area actually represent? It's not just some abstract number. An AUC score actually tells you the probability that your model will correctly rank a relevant document higher than an irrelevant one. A perfect score of 1.0 means it literally never makes a mistake. Now, to calculate that area, mathematicians need to pull out a special tool from calculus. And it's a symbol you've definitely seen before, probably in movies or TV shows. I mean, one person on a Wikipedia forum pointed out it was even in an episode of Torchwood. So, what is that funny-looking F thing? It's the integral sign, and its backstory is actually brilliant. That symbol is literally a long S, which was used in writing centuries ago, and it stood for summation, or, sum. It's the perfect symbol for a tool that's designed to add up all the teeny tiny little slices of space under a curve to find the total area. Okay, so the researchers put BRDC head-to-head against the older models, and they used this super rigorous testing method. It was time for the big showdown. So, how did it do?
Well, on the first test, the classic Reuters news dataset, the results were crystal clear. The old RDC method, it hit about 61% accuracy. Not bad. IRDC improved on that, getting up to 70%. But BRDC just sailed past them both, scoring over 73% accuracy. A clear win.
Then they ran the tests on a totally different collection, the 20 news groups dataset. And guess what? The exact same trend continued. RDC was lagging behind, IRDC did a bit better, but once again, BRDC came out on top, pushing past that 50% mark for accuracy.
And on a third dataset, AG News, BRDC delivered its most decisive victory of all. It scored over 56% accuracy, a full 5 points higher than its closest competitor. The verdict was in. Across multiple standard tests, this new balancing act consistently and clearly pays off.
Okay, so that's a definite win in the lab. But what does a few extra percentage points of accuracy really mean for us out here in the real world? Why should we care about this?
Well, it means the AI tools we rely on every single day get that much smarter. Better feature selection leads directly to more accurate spam filters that actually catch the junk without accidentally deleting your important emails. It means news apps that sort articles more reliably and systems that can analyze customer reviews for sentiment way more efficiently. At the end of the day, it just makes our AI tools faster, cheaper to run, and a whole lot more powerful.
This research is really one more big step toward an AI that can truly understand the massive, massive amount of text that our modern world runs on. And that leaves us with a pretty fascinating final thought. As AI gets better and better and better at reading, what are the most important things we should be asking it to read next?